In this lesson, we'll look at solving exponential equations. Sometimes we'll have some equations that we need to find the value of the variable. So solving exponential equations goes by the exponential equality property. So what does that mean? That means that in order for a power to be equal, it must have the same base and the same exponent. So for example, if we make a statement that says 3 to the power x equals 3 to the power 4, the only way these are equal is if x equals 4, because they have the same base and the exponents would have to be equal for the two equations to be equal, so that the left side, you want the left side equal to the right side. So when we have a question like 2 to the power x equals 16, we want to change 16 to the same base so that we can use this exponential equality property. I know 16 is 2 to the power 4. Once I have the same base, then I know that the exponents are equal, so therefore x equals 4. If I had 3 to the x equals 27, I want to change 27 to the same base, so I want to change it to base 3. I know 27 is equal to 3 to the power 3. Once I have the same base, I can say the exponents must be equal, so x must be equal to 3. Let's skip down to 4 to the y. We've got 256. We want the same base, so I'm just going to use my calculator to figure out what that value would be. I think it's 4. It is. So 4 to the 4 equals 256. Once I have the same base, therefore y is equal to 4. Just be careful with brackets and negative signs. Negative 3 has the brackets around it in G. So we want the same base to be negative 3. I can do that because negative 3 times negative 3 times negative 3 gives me negative 27. So I have an odd number of negatives. So that is okay. Okay, I couldn't end up with a negative number if I had an even number of negatives. In question H, we want to change the base 2. It has to equal negative 32. I know that 32 is 2 to the power 5, so negative 32 would be negative 2 to the power 5. And again, that is okay because 5 is an odd number, so if I have an odd number of negative signs, my result will be negative. And then this one, last one, A, I have A negative 5 to the power A equals 25. I know that 5 times 5 is 25, and I know that if I square negative 5, I'll get a positive answer, so that one works out too, where A would be 2. Sometimes we have more than just one variable. So for example, in A, still the same property that we're going to use. It is base 7, so I'm going to change 49 to 7 to the power 2. Remember, when you're changing bases, you always want to go smaller. You can't make bases bigger, but you can make them smaller. So 49 is equal to 7 to the power 2. Once I have the same base, I don't need the base anymore. I'm just going to make the exponent on the left equal to the exponent on the right, and then solve for the variable. In the next question, it is base 3 on the left, so I want base 3 on the right. I know 27 is 3 to the power 3. Once I have the same base, I don't need it anymore, so I have the exponent on the left, x plus 4 equals the exponent on the right, 3, and then we just solve for x. Let's do one more. Let's skip down to E. Again, I want the same base. I'm going to change 25 to 5 to the power 2. Once I have the same base, I don't need it. And now we're just going to solve for x. So we'll add 1 and then divide by 3. So same idea, change both sides to the same base. In these questions, you might have to change both sides. So remember, we always want to go smaller, never bigger. So I know 16 and 8. Well, I might try 4. I know 16 is 4 to the 2, but I can't write 8 as a base 4. So I'll have to go smaller than 4, so I'm going to go to 2. So I know 16 is 2 to the power 4, and I know 8 is 2 to the power 3. I'm going to apply my power rule. So that means 4 times 2 is 8. 3 times 3x is 9x. Once I have that same base, I can say 8x equals 9x. I'm going to solve for x. I'm going to bring the 8x to the right so that I have like terms. 9, 8 minus 8x is x, so x is 0. In B, we have base 4 on the left, base 8 on the right. I can't write 8 as a multiple of 4 because 4 to the 1 is 4 and 4 to the 2 is 16. So there's no 8 there. So I'm going to go smaller. I'm going to change them to base 2. So 4 is 2 to the power 2. 8 is 2 to the power 3. I'm going to apply the power rule to both terms. So don't forget both terms. So 3 times 2, or 3 times t plus 3 times 1. Don't forget to multiply the 1. Often we forget that. We only multiply the first term. Make sure you multiply both terms. Once we have the same base, we don't need it anymore. And then we're going to solve for t. I'm going to bring my 3t to the left, which leaves me with negative 1t. I don't want a negative 1t, so I'm going to divide by negative 1 to make it positive t. So t equals negative 3. All right, let's do C. 27 and 9 are both multiples of 3. So again, I'm going smaller. So 27 is 3 to the power 3. 9 is 3 to the power 2. We're going to apply that power rule to simplify those exponents. So we have 3x minus 3 equals 3 to the 4x. Once we have the same base, we don't need that base. And therefore x equals negative 3. And these are just a couple more similar questions. Let's just do, well, we'll just do one. D, I have to change both sides. A, I only have to change the 4, and B, I only have to change the 4, and C, I only have to change the 9. But D, I have to change both sides. So we'll change 4 to 2 to the 2. We'll change 8 to 2 to the 3. Once we have the same base, we can just work with the exponents. Oh, I think this was the same as the previous question. So 3x minus 2x equals negative 3. X equals negative 3.